Okay, so this is the question covered in the lecture by Dermot, and this is one we had in our midterm exam, and this is the one taken out of Anderson's book, and it's in surface geometry section, I'm pretty sure. Yeah, it is. And we're asked to develop it from the elevation and plan shown here. They're either missing a specification in the question stating that it's a hyperbolic paraboloid, or either or, there is a hidden intersection line between two surfaces, because either or these both these surfaces cannot be planar. They either have to be two surfaces or a curved surface, like the roof geometries that we do, the hyperbolic paraboloid, all those questions. So we'll go to SolidWorks. So I'll go to the auxiliary views here. So we have the elevation, the plan, and the end view. Okay. As we all know from simply inclined planes, as this is represented to be, from what it appears to be, they're stating that it's this line here is on this planar surface, but it can't be, and we can see this from the end view, which shows this ground line, which we could also view as a HT, as a horizontal trace, and we know that all lines on all true lengths, because this is a true length, because in plan it's represented as parallel to the XY line here. So first of all, this line either is wrong in elevation and should be horizontal, or they're missing an intersection line, because this needs to be raised up to the same height, so that these true length lines, parallel lines, will be true lengths in elevation on the same surface, because they have to be parallel if they're represented as true lengths. Okay, so moving on. So what I've done is this 3D sketch just to demonstrate it. This one here isn't the best view. I'll go to that. That seems good. Okay, so we've got this 3D sketch I did up. It's pretty simple. Okay, so to demonstrate that it can't be a smooth surface, I've done the construction, the generator lines for a hyperbolic paraboloid here, and that shows that it's very easy to see here in the bottom right that when we move it, that the generators, you can see the intersection here, whereas we know that parallel lines are always viewed as parallel, and that is true with a simply inclined surface, which this isn't. Okay, so that shows that this surface can be a hyperbolic paraboloid. Okay, so that's that. I'll hide that now. Oh, wrong one. Okay. Oh, wrong sketch. Show. Okay, that's hit. Perfect. So next we have on the far side, I've done the two surface intersection. So we can see that right now that this line would be the intersection, and in plan they'd have to show you this lamina, this surface here, and then this surface here, these laminas. This is a simply inclined lamina, whereas this is an obliquely inclined lamina. Oh, or is it? Yes, it is oblique, because in elevation this isn't horizontal. Yes. Okay, so I'm going to show you not this one. So this will show we'll have to go perpendicular to it. So this would be representative of an auxiliary to show the dihedral angle. So if we go here, it shows in plan that if we go look perpendicular to this auxiliary plane, plane 5, we go normal to, and we can see from here that when these 2 points, where are they? Oh, I forgot to show wrong one. Show. Okay, so what we're doing is we're looking along this line. Yes, down here. This is the horizontal trace, and if we this point here is that point there, and this demonstrates that it's not a straight surface, because if it was, then this would be a straight line, and no matter which way you look along a planar surface, it is flat. We all know this, okay? So next I did the alternative. So this curves in, whereas there's an alternative where it curves out. Where are you now? That's that one. Show. Hide. Show. Okay, so this is the alternative where it actually curves out. So we can see it here and here. So the previous one was going the opposite direction from the different points, and this one, okay? Goes backwards and forwards. Okay? Now to demonstrate this, we're going to look along it again through a second auxiliary plane where we're going to be able to see the dihedral angle between these two surfaces. We're going to look normal to, and down here we can see that this point here, and actually curves outwards. So if we want to, it's almost an Easter egg that Anderson put in his book for the metalwork teachers, I suspect. But if we want to get, sorry, 1 second. If we want to get, we know that these surfaces, this surface here, this surface back here, so we know, okay, this surface here we can get because it's planar. We know this because the edge view here shows us planar. Actually, we can know that from all four surfaces. This surface, the base square, because we're seeing a true shape of it currently. The back surface here, because we're getting an edge view of it, we can see that it's parallel to the right plane we have over here. But these surfaces here are not possible to develop. A common example of this would be turning the globe, the world map, and we know that you can't develop a sphere onto a flat surface. It just doesn't work, so we use cones and cylinders to map it. We map it onto cones and cylinders to visualize it ourselves. Okay, so that's been my explanation of this question by Anderson. This is wrong. Oh, sorry, let me be correct. So this surface is representing this surface A, I think, as Diarmuid had in the question. So A is correct because we know we can get this true length, and I suspect that's correct. I'm not whipping out the protractor here. I'm not whipping out my compass here and checking if it's correct, but I'll give them the benefit of the doubt. The back surface, it can be done. It's literally just rotating it out, keeping this width the same, and it'll project out, and it looks correct. Okay, I'm not going to go and check it, but these two surfaces are impossible to develop on a flat surface. So these two surfaces are wrong. So from that, this is an incorrect book on, I suspect, a book that's been widely distributed and endorsed by the university and its staff. But we can just show that everybody makes mistakes. Just don't take everything at face value and continuously question everything. Thank you, and that's my video. Please give me the 3D printing pen.